for SmartPlant 3D piping specs. I'm going to be joined by Stefan Bauer, who is a senior consultant, who will be doing all of the hard work this morning. The kind of format for today is we're going to go through this brief introduction, which is what I'm doing right now. We're then going to go through a technical overview with Stefan, so I'll be handing over to him for that. We've got a couple of quick poll surveys at the very end of that session, a summary slide, and then we're going to go into audience questions. So the whole point with the audience questions, please ask them as we go through. We're not going to respond to them right until the end of the session, and then we'll get through as many as we can. Now, overall, probably going to be around about 35-40 minutes, depending on the level of questions. Stefan's part is around about 30 minutes. So I think without any further sort of discussion, I'm going to hand over to Stefan to take you through the technical overview.
Okay, thanks, Andy. So, yeah, good morning as well to everyone. My name is Stefan Bauer, and I will guide you through this half an hour overview about quality assurance of 3D specs. Let me open for this a short slide about quality assurance of piping spec. What makes up the quality of a piping spec in 3D? So that means what do you need in a 3D piping spec? You have to make sure that all parts can be placed in a 3D environment. All parts have to be reportable, so you have to run, all parts have to be reported correctly. So that means, so what else do you need? You have to check your key attributes, something like face-to-face dimensions, face-to-center dimensions, and something like that. You have to make sure that your spec is complete, and maybe you also want to compare your 3D spec to a reference. For example, when this spec comes from SmartPlant reference data, you have to make sure that your 3D spec contains all the parts that you have defined in SmartPlant's reference data. So for this, I would like to show you some tools that helps to speed up this process and give you also the quality at the same time for your specs. For this, I would like to start with the Spec Tester at the beginning. For this, I open up the Spec Tester and I explain what Spec Tester is doing. What I would like to do here is to show you really in live how Spec Tester is working. So you see the GUI, you see the specs, you see output directory, and you start the test. I'm really doing this online now. That means Spec Tester is running. This is okay. This is a very small spec, but this procedure is just to see that how is the workflow. So Spec Tester is starting to create a pipeline. It starts to places all the parts in the 3D environment, and at the end a report is generated, and we will have a look at first into the 3D environment to see what is placed, what is the kind of reporting in this in the 3D environment, and we will have a look into our reports that are generated from Spec Tester and see what are the results on what results delivers Spec Tester, and how to interpret these results, and how this helps really to get to the points when something is missing or something is wrong in your spec. You see here, okay, you see here really how Spec Tester is placing part by part in the 3D environment. So Spec Tester takes all the parts of a piping spec and places or tries to place these in 3D. Okay, so I think so Spec Tester or the process already comes to the end. And creates a report at the end. Okay, so this run took about 2 minutes. Okay, that's fine. I open the output directory and let me at first open SmartPlant 3D. Okay, we get an empty screen. So, and we open a filter. This is our pipe spec, and all these parts are shown here from the spec. It's a very small spec, only 2-inch and 3-inch spec, but you see in the Workspace Explorer, okay, so this is a run. For every pipe size, a run is created, and all the parts in the respective pipe size are placed on the run. Good, okay. So when we look at the to-do list, you see this to-do list is delivered when all these parts are placed in SmartPlant 3D. You know this to-do list already. You can click on this, you can fit this, and so. For example, here is a problem. We have a valve, and in the spec there is, in this case, no mating flange provided with the spec, and this is what the to-do list says. Okay, this is the result from your 3D. When we look at our report delivered by Spec Tester, okay, we can see this to-do list as well. So in a more readable format, but anyway, so this is the same what is already delivered by the 3D environment. So we can look at this. There is also a report about placed parts and not placed parts provided. So that means every part is listed that is placed. There is no problem description. And for those where are problems, so this problem description is shown in this list. But this is a list of all parts. We also have a condensed to-do list entry, and here you can see really in a condensed form what is the problem. So we have a problem at a gate valve with 2 and 3 inch. There is no mating flange found, and the connecting part between piping, no mating flange found. And this definitely gives you a good overview about this pipe spec, about the quality of this pipe spec. And the person who is in charge for this pipe specs can directly go to this point, try to fix it in the piping commodity filter or in the catalog, and correct it, rerun the Spec Tester, and the goal at the end should be to have this list empty. And when this list is empty, you can this is a sign that everything is working, and gives you a good overview about the quality of your spec. Okay, so this is Spec Tester and the workflow of Spec Tester. when I switch back to my slide, bike load generator. This is another utility. It's a utility that is something like a complementary tool for Spec Tester, and also the story for bike load generator is very short. At the end, what is bike load generator doing? So bike load generator, you see the graphic user interface for bike load generator is quite similar to this of Spec Tester, but it does another thing. It really brings back your bulk load sheets from your 3D catalog. So that means you have a content in you have your specs in the 3D catalog, and bike load generator re-extracts all these sheets again from your catalog. So you may ask, so what this is good for, this utility, but sometimes it can happen that all these data, or all these when your spec is not in sync anymore with your bike load sheets, so this utility helps you to bring all the data back really when you have the content of your spec again in Excel. So especially when you develop specs in different places, or when you modify data directly in your catalog, so your bulk load sheets are coming to a state where they are not in sync anymore with your specs, and this tool helps you to bring you back these contents of your catalog completely. So that means you can have the specification data. You have the specification data in here, all you need, and all the catalog data, material control data. You can take this bulk load sheets, for example, bring it to an empty catalog again, and it's the complete bulk loadable format. And also in this way, it is possible to, let's say, to split a catalog. So it's not necessary that you deliver to a partner, to a contractor, or who else, your complete company catalog. In this way, with this bulk load generator, it is possible to split a catalog. You only extract the data, what you want, you have it in a neutral format, and you can deliver it to someone else. Okay, this is bulk load generator as a complementary tool for the spec testing tool. So when I switch back to this slide again, definitely when we are talking of quality of 3D specs, you need to run different reports on a spec that shows you how good is your quality, and yeah, in this process you often have to perform different various kinds of quality stacks, and a tool that helps, that gives a lot of possibilities, is definitely Universal Reporter. So maybe you already have seen this Universal Reporter and the respective adapters for it. For this, I open up a 3D, our CXpert 3D report adapter, and I would like to point out one functionality in this report adapter. Maybe you have this report adapter already before for extracting data from your model. So that means you have a model, and you can extract the data from your different tasks. This 3D report adapter also has the capability to report catalog data. So that means data which are not placed in the model can be reported directly from the catalog database. And okay, the way of working is quite similar to that reporting tool from the model. You just have to you just have to activate this task, piping catalog. You have to select the piping spec. You have to select the output database, and you run the extract. So this is absolutely the same what we do for extracting the data from the model. We can do it as well from the piping catalog, database. So when this extraction is done, we can open up the Universal Reporter and can look at this result. Okay. This is the result. Okay, this is our pipe spec in here. These are data from piping catalog, and these are the attributes from your catalog database. And here on the left side, you see the grid with the respective data. For example, let's assume you want to report, for checking reasons, you want to report this data. For this, you can define a spec report, for example. Let me open this template file, and you see, okay, this is a standard spec report from 3D catalog task with all the relevant parameters. And when you want to report this data, you can bring it easily to Excel with this, based on this template. Okay, I should activate this template. And based on this template, you have all your data from your pipe spec. This is your pipe spec. These are all the shortcodes which are in the pipe spec, first size from, and all this relevant data. You have it really quite quick in Excel, and this gives you a good overview what is the content of your pipe spec, and shows you also the quality. Okay, you can say, okay, are here all these data I need? Are all these data in the 3D? You can filter and sort, and you can do your checks on this based on a very simple Excel template. Okay, what else can be done with Universal Reporter? With the Universal Reporter, there is also a template for catalog reports delivered. And let me show you this report. This is a report with different sheets. And you see, okay, there is, for example, there is a general overview with the spec name on this sheet. There is a sheet where you can see all the part-independent data, something like service limits, corrosion allowance, and design code, and what else about the schedule thickness and wall thickness, about the data. There is a report part, and as well there is a branch table. And when I execute this template on my data from, in this case, on this pipe spec, you can see the result. I have here the result in here. And automatically all the data from this pipe spec are filled in this Excel template. So we have our cover sheet, so we have all the data in here that says, okay, this is this pipe spec, these are the service limits for this pipe spec, these are the nominal sizes from the smallest to the biggest one, and we have our schedule thickness and all these stuff. So you get a good information about, let's say, about the non-part relevant data. And here are the sheets for the parts. So you can define what kind of parts you want to see on the different worksheets. So this is for pipes and standard fittings. This is a sheet for fittings number 2, number 3, and all different kinds of fittings for the walls. And you can see all these information in a very, very readable format. So this is the part, this is the first size, this is the second size, this is material, this is the commodity code. And as well at the end, you also get a branch table. And I think this branch table, okay, this is the legend for this branch table. And you see your branch table in a very, very readable format. And this gives you definitely a good overview. Okay, is everything correct with my branches? You see it, okay, everything is colored according to this legend. And all this information directly comes out from Universal Reporter from this view when you execute it on your with this template. So just by pressing a button, you have this information in Excel. And for example, also you can deliver this to a contractor, to a partner, as a kind of documentation of your pipe specs. Okay, let me close down this and as well close this window. Let me come to another point. For example, when I have data from a different data source. So that means I opened up here 2 databases. One database comes from 3D. So this is a 3D database, and this is a database from Smart Plant Materials. So that means we have a pipe spec in 3D that originally came from data from Smart Plant reference data. So with an extractor we also have, it's called the Smart Plant Materials Data Extractor. We can bring this data from Smart Plant reference data or Smart Plant Materials into this Universal Reporter. This is the data from here. And when these data from Smart Plant reference data are loaded into Smart Plant 3D, we can extract the data and we have it here. So that means we have data from Smart Plant reference data, we have data in Smart Plant 3D catalog, and now we are able to compare these data from reference data with those from Smart Plant 3D. So for this, I drag and drop my data from 2D or from reference data to the data from to 3D. In the background, okay, there is a linked database. In this linked database, the criteria for comparing the specs is the spec name itself. We see, okay, this first application is from Smart Plant Materials. The second application is from 3D, and okay, I want to have the matching rows between both tables, and a new window comes up. So with all the relevant data from Smart Plant Reference and Smart Plant 3D. And based on a template, which I would like to show you, which compares the data from 3D and reference data, you can do a reporting. So in this template, for example, some very easy if statements can be embedded. So at the end, any kind of functions from Excel can be embedded directly in this template. And when I close down this and execute based on this template my report from this multi-window, you see the result. So that means when this template is executed and the report is created, we see the result, and the result says, okay, for example, there is something wrong with this commodity code. This commodity code is not in the 3D spec, and okay, this commodity code works well because nothing is reported. And you see, this is a possibility to really to check if the data from, in this case from reference data, completely has gone to SmartPlant 3D in this case. And based on very simple functions in a template, you can perform checks when you're using the data from this multi-window and execute it in Excel. So this is another example how this Universal Reporter or these different functionalities in Universal Reporter can help you to improve your quality of your specs. Okay, so when I switch back to my slide, that means we have seen the Spec Tester for the automation of part placement, the bulk load generator as a complementary tool for this Spec Tester, and these various possibilities for quality reports from Universal Reporter. Okay, so these are the checks that can be done for SmartPlant 3D as announced in our invitation for this webinar. And as a side topic of this webinar, we also have announced the PDS part. So the PDS, we call it Spec Manager in case of PDS, and this is the last part I would like to show you. For this, I switch in a PDS environment and show you the Spec Manager. The Spec Manager, okay, at the end it does the same as the Spec Tester for SmartPlant 3D. So, okay, the GUI is a little bit different, but for those who are familiar with PDS, so it's definitely no problem. And at the end, the workflow is absolutely the same. So that means you have a spec, you tick on the test for your spec, you start the test, and in this case, Spec Manager starts to place all the parts in PDS automatically. So what does it look like in PDS? When I go to my PDS project, okay, Piping Designer, Spec Manager automatically creates an area. In this area, for each pipe spec, own model is created. By the way, this is an automatic process. To do this, this is done directly by Spec Manager, and all the parts in PDS are placed automatically. So, okay, you can imagine how long this would take to place all these parts manually, and this is done in let's say half an hour, or it depends on the amount of parts that are in the spec. This is done in definitely faster than you would do it manually. Okay. So what are the results delivered by Spec Manager in PDS? This is quite the same, like in SmartPlan 3D. So here we have the spec name. We have the number of errors, and these are the parts that the person who is in charge for this pipe spec have to look at. There are some problems with a 6-inch butterfly valve, and so you can directly go to your catalog or to your physical data library. You can add the data they are missing, and this gives you definitely a good overview directly what parts are not working and what is working. So in this pipe spec we have 14 errors, and this definitely gives you a complete overview and shows you what must be done in this pipe spec. Okay, Andy, so I would like to switch now back to you.